Hi everyone, we're Team Auto Sapiens and we're here to talk about our project for Distributed Systems class. Our project is known as Carnegie Net or simply CarNet. You ask why? So let's give you a glimpse of our project. The days when you call an Uber and there is no person to greet you is not very far away. Welcome to the future. When there are all self-driving cars around, the infrastructure should better evolve itself too. Traffic lights and signals are for humans. Imagine roads without traffic lights because self-driving cars are too cool to stop for the lights. They would simply talk to each other and come up with a mutual decision as to who gets to go first. Maybe they could even pick an optimal path so that traffic jam is no longer a painful situation. The best way to model the situation is to model it as a peer-to-peer distributed system. So the main project idea is to implement a coordination among self-driving cars based on a P2P communication infrastructure. There are quite a few applications that come to my mind. So let's look into the scenarios that may happen. The first would be a stopping condition where cars at an intersection would have to decide which one gets to go first. Secondly, cars will have to adjust the optimal stopping distance between themselves depending on the road conditions. Another scenario is that one car wants to change a lane and there is another that is waiting on the same lane. In such a case, the two cars can communicate with each other and mutually decide on what to do and which car gets to go first, basically. All these situations require coordination, consensus, some failure handling, and security. Basically, a lot of DS concepts being applied here. So, we want to walk you through some DS features that our project will implement. Firstly, communication. In order to establish communication between cars, we plan to use an ad hoc network or communication infrastructure for nearby cars to automatically communicate with each other. On top of this communication layer, we want to design a distributed coordination system or some state sharing so that the cars can make intelligent decisions based on the information that they're sharing with one another. In addition, the system should be fault tolerant and failure handling is very essential. Vehicles moving may lose connection or connect to another ground station at any time. If one car goes down, then the car does not participate in the communication, and this way it achieves consensus with other peers. One potential solution is to allow a backup communication device in the car, but even if a car in the system goes down, other cars in the system should still be able to communicate with each other and reach consensus. Lastly, security is a big issue here. What if one of the cars is hacked? The Byzantine general's problem is back to haunt us. Moreover, scheduling applications should also be fault tolerant, so security plays a very important role. As evident from the brief discussion of our project, we can have multiple situations where we will be applying essential concepts learned in the distributed systems class. In order to implement an infrastructure like this, we need to overcome certain challenges, both technical and non-technical. These would ensure meeting the project requirements as well as coming up with a fruitful project. Some of the non-technical challenges that we have identified are listed as follows. The very first would be scoping the project. This basically involves finding the scope of the project and identifying some situations that may require DS features while keeping the application and the simulation scenario less complicated. We want to explore more and more opportunities for our project. We also think it is challenging to define some quantifying parameters for performance. Other technical issues that we think would be essential for this project is to come up with a new programming language and implement it. The communication infrastructure is based on an ad hoc networking infrastructure. So we would want to learn the intricacies about ad hoc networking, which would be a new skill for all the team members. The programming language Go is what we plan to use for the project, and it's going to be a very nice skill to learn. Also, simulations, emulations, visualization is another field to explore. We plan to implement a UI-based simulation using GoQt or Go's draw package for demo purposes, depending on the feasibility. In addition, implementation of failure handling algorithms will be a big task, but we plan to overcome these challenges through our consistent efforts and teamwork. So, this was a quick summary and a brief overview of what we plan to achieve in our project. Thank you so much for listening.